Welcome to the Robert E. Lee Science Fair. We are very proud of our rebels. Our fifth grade rebels and fifth grade teachers have been working very hard with the science teaks. The students are excited to work with testable experiments, testable hypotheses, and they are coming out with wonderful conclusions. They are looking at their factors, and they are very proud to explain this to the rest of the rebels. First through sixth grade is involved in this wonderful science fair, and I credit the staff and the students for that.
Hey guys, this experiment is called bending light. Now, it's simple refraction, aka, which means a change in direction that light undergoes when it enters a medium in the different distance from one another through which has been traveling. This is what the experiment is supposed to look like. Now, as you see right here, with this normal jar, when it goes here, and you turn on this little flashlight, alright, now, when it passes through right here, you can see that it intersects that. But if it's normal, like this, and it just passes through, it doesn't really do anything, like at all. So as you see, the arrows originally in this direction went in the glass cylinder or plastic. It just changed. Like this.
The direction is the opposite.
Que es un circuito cerrado y abierto. Como ahorita es un circuito cerrado. Es un circuito cerrado porque no está temblando. Y cuando estamos jugando, tratamos de que llegue hasta allá sin tocar. Y ahorita está tocando y es un circuito cerrado. Y ahorita es un circuito abierto. Y ahorita está tocando y es un circuito cerrado y está sonando. Y tenemos que llegar que no toca porque si toca va a temblar el timbre.
First, we did a pedal boat, which was our investigation, and we did different types of pedals to see which one was worked best in order for the boat to advance further. So then we saw like examples which were like Leonardo da Vinci's, which he made, the mechanical boat, and then we put it into progress. And we used different kinds of materials, and we used the rubber bands, the juice box for the paddle, and then we used some pencils, a bottle for the boat, and then we used a toilet roll, which was to balance it a little bit, and then some straws if you had to. Also, an example for the two pencils, we used clay to weight it up, and then a meter stick to measure the different kinds of measurements that the boat went. At first, we thought that the wood one was going to go further, but at last, how it was too thin, it kind of did not resist much water, and it broke. The second one, which was B, the waxy one, they worked good because that one it's already used to be with liquids. C, which was the cardboard, it did not work that good, but it did work good because we put it with some tape. And it did not work that much because it soaks up too much of the water in it. And then D, which was made out of plastic. It was made out of plastic cup. It did work, but it did not work as much as the waxy carton, which was almost the best in all. And then our hypothesis was wrong, so then we made a conclusion to make it better, to make it a little bit more better than the other one, which was thinner. So we used lots of different materials for the pedals, and then we did demonstrations. Which was to wind it up and then just let it go. and that was why it worked better.
Our project are float or sink. Problem: which soda has more density? Coke, Diet Coke, Dr. Pepper, or Big Red? Hypothesis: if you put the different kinds of Cokes like Coke, Diet Coke, Big Red, or Dr. Pepper in the water, then you will see Diet Coke and Big Red flow because they have less density. We think they have less sugar. Materials: 4 cans of different sodas, 1 container, and water. Produce steps: fill the container with water, put the sodas in the water, observe the sodas to see which has more or less density. My short. Arlie Neal, the Science Book of Water, and Diego Gilbert books, Breeze and Company.
We're gonna do a project of the force of water. The question we are gonna do is, can water be used to lift heavy things? Our hypothesis is, if you put a balloon inside of the bottle, then the balloon needs to get space, volume, and makes the water get displaced. The materials that we are gonna need: 2 bottles, 5 balloons, 1 clay, watercolors, 1 straw, 1 cap, and 1 bag.
Procedure.
The procedures is, first we're gonna cut 2 bottles at the same level. Then we're gonna do some holes in the bottles. Then we connect the bottles with a straw. In fourth place, we put the clay on the edges of the straw. Then we put the water in the bottles. Put food coloring inside the water. Next, we put a ball inside of the bottles. Then we ball up a balloon and put it inside the other bottle. Then we push down the balloon and the water will get displayed on the other bottle. My conclusion. Yes, our hypothesis was correct. We put the balloon in one bottle and the balloon took the space, volume, and then pushed the water in the other bottle and they make objects live.
The purpose of the question is, does a model help you understand the solar system? Our hypothesis was a linear model helps you understand the order of the planets, and the 3D model helps you understand how they orbit the sun. The materials we used was foam balls, sticks, and paints. The procedure, the step: first we paint the foam ball, then we put the planet in order. Last, we put the planet to the sun, and we do a draw from the planet. Our conclusion was the linear model helps you to know what out of space, how big or small something it is.
Today we're gonna do the experiment of balloon power car. Our question is, on which surface, tile or gravel, will the balloon go further on? Hypothesis: if we put the balloon powered car in the tile, then it will go further than on the gravel because it's smoother and has less friction. Materials: 4 bottle caps, carton, balloons, straw, tape, measuring tape, meter stick, bamboo stick, gravel. The procedure steps. Get your cardboard and cut it by 2 inches by 6. Get 2 straws and cut them 2 inches long. Put 1 bamboo stick through a straw and do the same with the other one. Tape them at the end of the cardboard. Stick your bottle caps on each side of the bamboo sticks. Get the balloon and a straw. Tape the straw where you blow the balloon. Where the balloon, you just tape the top of the carton. Conclusion. The balloon power car went faster and farther on the tiles.
Today we're gonna talk of magnetic levitation. We made this project in the bottom right here. It's the force of repel and push. If you see right here, we showed an example of what magnets could do. And if you can see, it's repelling from each other. If you see right here. First, we need to gather everything we need. Number 2, do 2 figures and a stage. Number 3, cut your figures and put a magnet next to the one you are gonna levitate. Number 4, then you put the other magnet under you are going to levitate. Number 5, make sure you face the same poles together because that is what will cause the levitation. 6, but make sure you put a small pencil or a piece of wood between the magnets. The conclusion, our hypothesis was correct, but our model didn't work as we expected it to. One of the magnets kept flipping. We think it happened because the magnets were too strong. Instead, we did another model using simple materials, such as a pencil with 3 rings magnets. This worked better than the first model we did.
Lava lamp comparison. The procedures are the steps. You can get 2 water bottles. You get the vegetable oil, fill it up almost to the top. Then add the food coloring. Wait about 20 seconds. Put 2 Alka-Seltzer pills and watch the lava lamp bubble.
Our question was, what kind of oil will create bigger lava lamp bubbles? Vegetable oil, vegetable or olive?
The hypothesis is if you use olive oil instead of the vegetable oil, then you will have bigger lava lamp bubbles.
Our materials were 2 water bottles, two small bottles of blue food coloring, 1 bottle of olive oil, 1 bottle of vegetable oil, one small bottle of Alka-Seltzer, and one beaker and 1 flashlight.
The conclusion, the vegetable lava lamp was the best. It made better lava lamp bubble than the olive oil. The olive lamp was a mess. It didn't bubble as much like a lava lamp.
What we're doing right now is yeast feeds. Yeast is a type of fungus. And we're using sugar. So what we're using, when the yeast is eating the sugar, it's making carbon dioxide. And hypothesis, if you put 20 grams of sugar, then the balloon will inflate bigger because more carbon dioxide will be released.
Procedure 1. Fill the bottle with about 1 inch of warm water. When yeast is cold or dry, the microorganisms are resting. 2. Add all of the yeast packet and gently stir the bottle a few seconds. As the yeast dissolves, it becomes active. It comes to life. Don't bother looking for movement. Yeast is a microscopic fungus organism. 3. Add the sugar and swirl it around some more. Like people, yeast needs energy, food, to be active. So we will give sugar. Now the yeast is eating. 4. Blow up the balloon a few times to stretch it out and then place the neck of the balloon over the neck of the bottle. 5. Let the bottle sit in a warm place for at least 20 minutes. If all goes well, the balloon will begin to inflate.
Our hypothesis was correct. The balloon that had 20 grams inflated bigger.
Hi, this is the electromagnet, and if you want to do this project, first you're going to need a battery, a large nail, and some copper wire and some paper clips. First, you coil the wire around the nail. Second, you connect the wire to the positive and negative of the battery. Right the point of the nail, pick up the paper clips. Disconnect the wire so that the paper clips fall back down. Separate the wire on the nail and find out if the nail picks up more or less paper clips. Our hypothesis was correct. The nail with the lighter coils picked up more paper clips.